Hi everybody, my name is Julian Miller and I would like to welcome you to my first ever video tutorial. In this video I plan on just going over some of the basics of C++, some of the things that you will need to be aware of when you're starting off programming, object-oriented programming rather, in C++. The first thing I'm going to cover is pointers, because they play a huge role in object-oriented programming, especially in C++. So you can see here I have a basic template set up in Microsoft Visual Studio. You can use any text editor you want, you can use any IDE you want. I'm not going to be using anything specific to Visual Studio, but I do recommend that you follow along at home just so you can get a better feel for what is going on in these videos. So, what exactly is a pointer? A pointer is essentially just like any other variable, except rather than storing a value that you're going to use directly, what it does is it stores an address to some other value. And we can make this more concrete with just a simple example. What I'm going to do is first declare a pointer. So this is telling us that we want a pointer p, and it's going to store the address of some other integer. And a good habit to get into is to initialize your pointers to 0 or to no. It's kind of personal preference. I like using 0. I just think it's cleaner than using a macro. And I guess I have a diagram here that I can show you, or rather a table. And it's just showing you exactly what's going on in memory here. So here we have a bunch of memory addresses in our RAM. This is going to be the memory address for our variable p here, and we're putting the value 0 into p. Next, what we're going to do is just create an integer x equals 10, and there we go, we have the value 10, and we're putting that in this memory address here. So this is our memory address for x. Next, what we're going to do is we're going to assign p to something new, and this is the ampersand of x. And this ampersand, what this is it's telling us not to get the value stored in x, which is 10, but it's telling us to get the address of x. So back to our diagram here. What we're doing is we're taking the address of x and we're putting that in for the value of p, which is our pointer. So now p is pointing to this memory address, which has the value 10. And what we can do is we can print out all these variables just to get a better understanding of what they all mean. So what we're going to do first is just print out the value of x, which should be 10. Then we're going to print out the address of x. Then we're going to print out p, which should be the same thing as this address of x, because that's what we're setting it to here. And then I made a mistake here actually. This should be the dereference operator, which is this asterisk. And what this is doing is, instead of printing out whatever's stored in p, this is going to refer to whatever is in the memory address pointed to by p. So rather than returning p, this asterisk dereference operator gets the value that is pointed to by p. So we should get 10, which is equal to x. Now you'll notice that cout, there's an error here because it thinks it's undefined, and that's because it's in the standard namespace. So what we could do is type std in front of all of these terms here, or we can tell the system that for the remainder of this file we're just going to use the namespace std. So now all those errors are gone because it knows where to look for these items. And if we run this, we can see that the value x is 10. The address of x is this value here. P is storing the address of x, and if we get whatever P is pointing to, it's 10. So that's good to get a kind of a general understanding of what pointers do and what they are. But why is this useful? Well, pointers allow us to dynamically allocate and access memory. So let's get a better example of that here. What we're going to do is we're going to dynamically allocate an array and just print it out for simplicity's sake. So it's going to be a simple example, but you should be able to see how this is useful. So we're going to make size. So this is going to be the size of our array. We're not going to initialize it to anything for now. And we're going to create a pointer. So this is our array. Perfect. Now what we're going to do is we're going to ask the user for the size of the array. And what we're going to do is we're going to create an array of that size. So normally you'd have to, I guess if you weren't using pointers, you could only statically, or I guess allocate memory on the stack with an array, which is of constant size. So what we're going to do now is we're going to use something new called the new operator, or new term, and we're going to set that to our array. So what is this doing here? In memory, just ignore this 10 right here. This is going to be, well, say we'll set this to 10 for now. Say we commented this out for now. So this actually isn't going to take place, this part here. So we have the size of 10. What we're going to do is we're going to allocate new memory and enough for 10 integers. So here we are, we're allocating new memory for 10 integers, and here is our array variable here, and we're going to put the address in here, and our dereference operator is pointing to the first element of the array. So what we can do is we'll just assign each element of the array to I, just for simplicity's sake. And we'll output that. Perfect. So, if I didn't make any mistakes here, this should compile. And just to give you an idea of how we're actually accessing this, because this is a pointer, right? How are we using it as if it were a regular array? Well, what we're doing is actually, these brackets indicate that we're incrementing the pointer by a certain amount. We're giving it an offset. So when this is 0, we're pointing to this element right here, and we're going to just make this 0 because I is 0. On our next iteration, the offset is going to be 1 because we go I++, and the offset is 1. So we're moving up an extra memory address here from the base address, and we assign that the value 1. And we're just going to run this. There we go. It goes up to 10. Makes sense. We'll close that. One thing I forgot to do was delete this memory. Because we're allocating new memory, one thing you should always do is delete the memory after it's been used. So this will free the memory. And it's important to do this because if we don't do this, we're going to end up with this allocated memory here, and it's just wasting space. It's wasting resources. So always delete any new. You should have the same number of news as deletes in your program. And we're going to get rid of this just to show you kind of how input would work with this. I guess we can leave that as 10, or we can get rid of it. And we'll run this again. It'll ask us for an array size. We can enter 20 now, and it will dynamically allocate enough memory for 20 integers, go through them, and print out these array elements. Great. That's exactly what it does. So that's all I'm going to talk about in regards to pointers. If you have any questions, feel free to comment and I'll try to answer them. Next, I'm going to talk about structs because they're fairly close to objects or classes in object-oriented programming. So it's fairly straightforward process to declare a new struct. What we can do is we'll just do something simple. Again, I'm assuming that you have seen structs before. I just want to review them to make sure we're all on the same page here before I go into object-oriented programming. So we can give this dog a name, and we'll give it an age. What I'm going to do is include the string header so we can make use of strings. And it's fairly straightforward. We can treat this as if it were a new type now. So we have a new type dog. Dog D, we'll just give it a single letter variable name. You should never do that in practice because it gets really confusing. And we'll name this dog Spike. And we'll make our dog 2 years old. And just to show you what this is, so we can compile something. There we go. Okay, so this should output the dog's name, which is Spike, and the dog's age, which is 2. We'll compile it and run it. Whoa! Definitely didn't mean to do that. Sorry, guys. And there we go. Perfect. Okay, and what we can do is we can actually define functions to help us modify this. So above our main function here, we're going to make a new function called initDog, which will be a function to initialize a dog. Dog D, string name, and int age. And we'll declare that or define that under our main function. I guess we have to give it a type. We'll just use void. We don't want to return anything. And we'll just set dog's name to the name that we input and the dog's age to the age that we input. Okay, great. So we should theoretically be able to call this now and change our dog's name and age. So let's do that here. So we'll pass in our dog D, and we'll give it a new name, and we'll give it a new age of 4 years old, say. So when we print it now, we should end up with our new name of Santos L. Helper and an age of 4. But that's not the case. It's still Spike, and our age is still 2. And the reason for that is because when we make a function call, our program is actually making a copy of this dog D, and any changes made to it are local to this function. So what we can do is use the reference operator that you saw earlier to fix this. And that's the ampersand. What this does is it tells our program to, rather than make a copy, edit the actual dog or modify the actual dog that we pass in. So rather than passing in a whole new dog and making a copy of it, we're just taking the address of the dog and making changes to the dog that we pass into it. So that should fix the problem that we saw before. We'll run it, and there we go. So that's another thing to always remember, is that in function calls, any variables you pass in, unless they're passed by reference or by pointer, which we'll see later, any changes made to them is going to be local to the function, and it won't affect anything outside of that function. And I guess I can just finish off with the last few minutes here and talk a little bit about namespaces. There isn't much to say about them, other than the fact that you can create your own namespaces if you didn't know that already. So say we wanted to call this string instead of dog. Well, we run into a problem now because we have string here. How do we know whether we're talking about our string or the standard library string? What we can do is we can define this in our own namespace, and we just do that by saying namespace my space, or whatever you want to call it. I guess that's kind of that's an online kind of social networking thing, so we'll call it something else. Maybe we'll just call it, I don't know, dog space. There we go. So there's our namespace. If we want to use our dog D now, we'll just change this back to dog. We use this scope resolution operator, and it fixes all the issues we had. Likewise, we can say that for the remainder of this file, we're going to use dog space, and it clears up any errors rather than having to type dog space : dog every time we want to use it. And namespaces are handy because it solves a lot of issues that come up when you're using global variables. Not that you should use global variables. You know, there are certain cases where they're very important, but you should be very careful with them because, like I just demonstrated, you can have multiple things with the same name. You can have two different types called string. You could have two different dog types. You know, it can get really complicated when you start working in bigger projects. So it's very good to kind of give them their own space and separate them out a little bit. So that's all I'm going to talk about in this tutorial. I hope you learned something, and thanks for watching.